Right, this video is on scientific notation, the basics of scientific notation, how to write numbers in scientific notation, and how to take numbers out of scientific notation and into what we call standard notation. So scientific notation is something that is probably not new to you. It is something that you have learned about probably in both math classes and in science classes, but we use it so often, especially in chemistry, and so we need to make sure that everybody has a foundation in scientific notation. So to answer this first question on our note sheet of why do we use it, basically we use it to eliminate zeros in numbers, and sometimes we use it to take a really big number and eliminate those zeros, maybe the distance from Earth to the moon. Say, and sometimes we use it for the opposite, to take out all the zeros in a really small number, like, for example, the diameter of a cell. But basically, it's just to eliminate those zeros, and it's kind of a shorthand method. Okay, so what's it based on? Well, it's based on multiples of the number 10. Okay, and I'll show you how that works in a minute. Some of you maybe have never really understood the idea behind scientific notation, and so I will show you that in just a few minutes. We're going to learn later, of course, about how all of science is based in the metric system, and of course the metric system is also based in multiples of 10, so scientific notation and the metric system are very similar in that regard. Okay, so of course we've all seen examples of scientific notation, so it looks something like this. 6.02 times 10 to the fourth, where this 6.02 is the coefficient, so to speak, just like in math class. And for scientific notation, that number has to be between 1 and 10. So basically, it has to be greater than 1 and smaller than 10. And so 6.02, of course, fits that bill. It's greater than 1 and smaller than 10. All right, and then we always have the multiplication sign. 10, again, it's based on multiples of 10, so we have that times 10, and then to some power. Some of you might call this I call it a power, some of you might call it an exponent. Either one will work. And basically, that number tells us how many times we move the decimal, okay? So you might want to write that. It tells us how many times to move the decimal when we take this number out of scientific notation. Now, depending on who your teacher was, who taught you this, let me move that, who taught you this before, you may have learned, or you may have memorized, you move the decimal to the right, you move the decimal to the left when blah, blah, blah. I find that students sometimes get confused by that. So I teach something a little bit different, which is this. So you might want to jot this in, where you still have room. So I teach, let's see, if the power is positive, then the number is greater than 1. Okay, or often I refer to that as a large number. And if you think about it, so if this power is positive, which of course it is in this example, the positive 4, this number is going to be greater than 1. And if you think about that, which way you would move the decimal to make this number greater than 1? Well, you'd have to move it to the right to make that number a large number. So that's how I kind of teach it instead of memorizing left versus right. But again, if you learned it that way and it makes sense to you, that's fine. So then the opposite is also true. If the power is negative, the number that we're working with is less than 1, which means, of course, it's going to be a decimal, right? It's smaller than 1. It's going to be a point something or a 0 point something, no matter, however you write that. So that's kind of how I teach it. Again, if you... if that totally makes sense to you and you've learned it left versus right, that's perfectly fine. But that's how I do it. So, real quick, let me get rid of some of this so that we can do this practice example. So in this number, the 6.02 times 10 to the fourth, So we've already said that power is positive, which means it's going to be a large number. And if it's going to be a large number, I'm going to need to move that decimal point to the right, and I'm going to need to move it 4 times. So, of course, we start like this. We move it once, which would be 60.2, right? We move it twice, which would be 602, but we've only moved it 2 times of the 4. So now I have to tack on zeros, move it 3 times, move it 4 times, and there I'm done. I can go back and count 1, 2, 3, 4. And so my number is 60,200. Now, if you put that decimal point here, that's fine. But of course, we know that it doesn't really have to be there. So that's your first introduction to scientific notation. There's some practice on here. So let me go ahead and clear my screen. And we'll do the practice. So the first practice says, write the following numbers in scientific notation. So let's see. And again, if you want to just do this and then check to see if your answers are correct, that's perfectly fine. But I will walk through these. Okay, so write the numbers in scientific notation. So again, thinking about the fact that, remember in our example, we had 6.02 times 10 to the 4th, and my rule was that this coefficient had to be between 1 and 10, right? So what I'm thinking about is, where am I going to put that decimal to make those numbers between 1 and 10? So in this first one, I would want to put it right here, right? Making that number 7.2. And then we think about, where was the decimal point originally? Well, of course, originally it was all the way out here to the right of that last 0. And then all I do is count how many times I moved the decimal. What we want to think about, though, is that number was a really big number. So my exponent is, or my power, whatever you want to call it, is going to be positive. Again, some of you have learned that if you move the decimal point to the left, it's positive, and so on. But that switches when you take it out of scientific notation. So that's the only confusing part about memorizing left versus right. So anyway, so it was a big number, greater than 1, which means my exponent's going to be positive, and all I do is count now. 1, 2, 3, 4, 5. So times 10 to the 5th power, and I'm done. Don't feel like it's silly to write these little squiggles, because it really helps you to count the number of decimal places. All right, so in my second one, notice my decimal point's already here. It's a small number, right away. Based on my rule, that should tell you that your exponent's going to be negative. It's already a decimal, it's less than 1. So I want to think about, where do I want to put that decimal so that it's between the numbers 1 and 10? And that would be right here, right? Because that gives me 3.18. And then all I do is count my jumps. 1, 2, and 3. We already said it was negative, so 3.18 times 10 to the negative 3. 0.4 times, so I know I'm getting ready over here. It's a decimal number already. It's going to be a negative. Where am I going to move that decimal point? Only to this side makes sense, making that number 4. And how many times did I move it? Just once. So 4 times 10 to the negative 1st. And number 4, if you think about that number, 50,000, right? That number is a large number. It's going to be a positive exponent. Where am I going to put that decimal point so that it makes it between 1 and 10? And that would be between the 5 and the 0, giving you 5.02. The decimal point was here originally. And so all I need to do is count my jumps. 1, 2, 3, and 4. 5.02 times 10 to the 4th power. And then number 5, the number 9 in scientific notation. Some people might say, you can't do it. Well, actually you can do it. And so it's the issue is that, how many times do I have to move my decimal here to make this number between 1 and 10? Well, I don't have to move it at all. So in scientific notation, the number 9 would be 9 times 10 to the 0 power. And we'll come back and talk about that in just a minute, because that's important that you understand something in just a few minutes. So let's do the second part, which is writing them in standard notation, which is, of course, kind of regular numbers. Give me just a second. And so writing these in standard notation, I'm just kind of doing the opposite. I think about the fact that this negative means it's a number that's smaller than 1. So I need to make it a decimal, meaning I need to move the decimal point to the left so that that number becomes very small. I need to move it 6 times. So if you think about the number 5, the decimal point is right here, and I need to move that decimal point 6 times. So move it once, and I run out of room, so I start adding zeros. So move it once, move it twice, move it 3 times, and so on and so forth until we've moved it 6 times, which is going to look like this. Move it once, move it twice, move it 3, move it 4, move it 5, move it 6, and my decimal point is there. So this number is 0.0000005 or 0.000005, either one. But that decimal point must be there. Changes the value of your number if you omit it. Number 2, 2.7 times 10 to the positive 2. So I need to make this number a number greater than 1, means I'm going to go to the right. I'm going to move it 2 times. So 2.7, move it once would be 27. I need to move it twice, add a 0. So my number is 270. 6.1 times 10 to the negative 1. I'm going to move it to the left to make it a decimal. Move it 1 time. So 6.1, move it once. My number is 0.61 or 0.61. That doesn't change the value of the number. It's just a placeholder. And then number 4 is a positive exponent. I need to make this a large number. I'm going to move it to the right 3 places. 8.97. So move it once would be 89.7. Move it twice would be 897. Move it 3 times, you need to add that 0, which makes this number 8,970. Of course, you don't have to have this decimal point. You can put it there if you'd like to. You can also put a comma. Just make sure a comma doesn't look like a decimal. Okay, so just real quickly, I just want to explain to you the reason behind why scientific notation works. And so take a number like, 2.5 times 10 to the second power, right? Well, if you write that in standard notation and you move that decimal point twice, you get the number 250, okay? But why do you get the number 250? Well, because I want you to think about this. So this is a math problem, 2.5 times 10 to the second power. Well, 10 to the second power is 10 squared, which is 100. So basically, this is 2.5 times 100, which I'll be darned is 250. Okay, so this is why scientific notation works. Same with the one I just talked about with the 0. This is the one that I think is pretty cool. So if we had, I think it was 9 times 10 to the 0 power, okay, which of course we learned just a minute ago is just the number 9. Well, 10 to the 0 power, hopefully at some point you've learned that anything raised to the 0 power is the number 1. So this is really 9 times 1, which is of course 9. And so we see that we have a matching relationship. This is why scientific notation works. Okay, it also works with a negative exponent. It's just a little harder sometimes for students to understand. So 10 to the negative first power is a tenth. It's 0.1. Okay, so this is really 3 times 0.1, which is of course 0.3. And if you had taken this out of scientific notation, you would have said move it 1 place and it would be 0.3. And we notice we have a matching relationship. So that is how, or I guess I should say why scientific notation works. And in chemistry, especially a little bit later on, we deal with numbers that are really, really big. And so we will be using scientific notation very often. So it's important that we understand what these numbers mean and how to write numbers, both in scientific notation and then take them out into standard notation.